Okay, guys, in this unit, we're going to continue to learn how to prove triangles are similar. Remember those guys, SSS and SAS? We talked about it when we were evaluating if two triangles are congruent, right? And here they come back again when we try to prove that triangles are similar. Remember, by definition, two triangles are similar if there are two conditions. A, all the angles have to be congruent. And secondly, all the sides have to be proportional, right? So they have to be proportional. And so because of the second reason, we can use side similarity theorem, which states if the corresponding sides of two triangles are proportional, these are your keywords, the corresponding sides are proportional, then the triangles are similar. And so in this example, as we can tell that this and this side is AB and FG. So they use FG divided by AB. So notice that they went from the smaller triangle to the bigger one. And then with the other corresponding sides, we have to do the same. So GH, which is the second part here, and BC is the base here, the corresponding angle, the corresponding side. Finally, HF, which is the longest side, and AC or CA, because they went HF, we have to go CA. So each of the letter H and C, right? Each of the letter is corresponding to each other so that the directions of the sides are the same. So if all of these are equal, all of these ratios are equal, all three sides, then we say triangle ABC. Again, be careful with the sequence of the letters because these big letters represent the angles. FGH are similar. Again, if we take angle A is corresponding to angle F, angle B is corresponding to angle G, and angle C is corresponding to angle H. So the sequence really matter here. Okay, so let's see how we use this. Here we have two triangles. We're asked to write a similarity statement and find the scale factor. The scale factor is what we just talked about earlier. These are called scale factors. All the ratios of the corresponding sides are called scale factors. So first of all, we have to write a ratio of corresponding sides and then determine if they're similar. So SU is 6, PR is 12. If I simplify that, reduce that, I would have 1/2. And UT is 5 and RQ is 10. And if I divide it by 5, I also have 1/2. And TS is 4. QP is 8. Again, I have 1/2. Voila, look what do I have. All three are 1/2. So because of that, all the ratios are equal. So the corresponding sides of the triangles are proportional by definition or by SSS Similarity Theorem. The triangle PQR, this is my similarity statement, is similar to triangle STU. And the scale factor of angle B to angle A, remember this is of triangle B to triangle A, is 1/2. It has to go from this side to that side. As you can tell, when this is 1, this is 2, twice as big. Okay, so not much new concept other than the scale factor, which is just the ratio between the corresponding sides. Finish the follow-up and then let's look at example 2. We have to determine is either DEF or GHJ similar to ABC? So let's first look at the, because all three sides are given, we first have to look at the proportions of the corresponding sides. And the way to do it is to look at two triangles and determine which one is the shortest side. DE obviously is my shortest side because 4, 6, 8, right? So DE is 4. And in this triangle, the shortest side is 6. And if I simplify that, I would have 2 over 3. Now I go for the longest side. The longest side is 8 in this smallest triangle, and in this one is 12. So I have 2/3 as well. And then finally the last side, thank God there's only 3 sides. It's a triangle, so I also have 2/3. You all are pro now, so you know because all the ratios are equal. Oops, equal. Triangle ABC is similar to triangle DEF, right? Then we do the same thing with the other two triangles. So with the third one, so we do GH divided by AB. GH is the shortest side, so that's 6 over 6, that's 1. Then we do the longest side, which is JG over CA, and that's 14 over 12, and that gives me 7, 6. I can actually stop here because I already have 2 ratios that are not equal, therefore I don't have a scale factor. But if you want to finish the third side and you're curious about it, we can see third side doesn't equal as well. So 3 ratios, 3 corresponding sides have 3 different ratios, and therefore the ratios are not equal to each other, and therefore these 2 triangles are not similar to each other. Okay, so that's our SSS. And make sure you finish the follow-up and the checkpoints before you move on to the next example. Next, we have another way to prove it. Sometimes not all 3 sides are given. However, we're given that one of the corresponding angles are congruent. And again, you're familiar with this. So it says that if an angle of one triangle is congruent to the angle of the second triangle, so angle X and angle M are congruent. I'm going to fill this in. And the length of the sides that includes these angles are proportional. What does this keyword include these sides? It means that I have to look at, if I use blue, this angle, this side and this side, that's one pair of corresponding, and XY, XY and MN. Look at these 2. Why am I picking these 2? Because these 2 sides form these angles in between, these angles that I'm filling in between, right? So these 2 sides includes these 2 corresponding angles. And the side opposite of that angle, ZY, PN, opposite of M, have nothing to do with it. So, but if these 2 are proportional, then the triangles are similar. So in other words, if PM over ZX is the same, what is it? The red one is NM or MN over XY, then these 2 triangles are similar. Let's see how we do this one. We have to determine if they're similar. The good news is that we've got one pair of angles that are congruent, and that's angle C and angle F. That's congruent to angle F. So I have my A, right? I have my A in the SAS. Now let's look at the 2 sides that's including these two corresponding angles. The shorter side is DF, and the other shorter side is AC, so that's 5/3. Now let's look at the longer side, which is FE/CB, which is 10/6 if I simplified that. I also have 5/3. So they're proportional. Therefore, we can they are proportional. And these are the scale factors, basically. So by SAS, we can say triangle ABC is similar to triangle DEF. Okay. So when two sides and an angle is given, make sure that it's two sides that includes that angle, and then go for SAS. Let's look at another example. We have to show that this little bitty triangle on top is similar to this big triangle that includes that little bitty triangle. So if you want, you can, let's see if I can do this. If you want, you can take this little bitty thing by itself. Oops, what did I do? Sorry, guys. Where is my shape recognition? Yeah, it's not the best triangle. Let me see if I can give us the solid line. It's a little longer, okay? And then the big one looks like that, something like that. And then you can label it. So on the top is VWX. And this is 4, 5, I don't know this side. And the big one is VYZ. And if this part is 4, this part is 8, altogether I have 4 plus 8, which is 12. And on the right-hand side, I have 10 plus 5, which is 15, right? Make sure you do that little bit of arithmetic there. So now, excuse me, as you can tell, because I have an angle V and an angle V. And remember this, angle V is congruent to angle V by reflexive property of congruence. And that is just like a mirror image, so to speak, right? And then we go for the sides. So let's go for the shortest side, VW and VY would be 4/12. 4/12 is 1/3. The longer side is XV/ZV, I think. And it's 5/15. Voila, look at that. So the length of the sides that includes the angle V are proportional. And the scale factor is 1/3. So now we can draw the conclusion. The similarity statement is triangle VYZ is congruent to triangle VWX. Okay? So if you are to conclude, if you're given the length of 3 sides, go for SSS. Look for for 3 sides, the corresponding sides to be proportional. If you're given an overlapped triangle like this, because it's given that this overlapped angle V is congruent, you can use your SAS. Or if you have 2 separate triangles, like what we saw in example 3, where you're only given information of 2 sides and the information of 1 angle, the included angle, then you are all set to use SAS. Okay, guys? I hope this is helpful, and I'll see you in class.